Electricity is one of the many modern marvels we take for granted. From the moment we wake up to the moment we lay our heads, it is in every part of our daily routine. From small appliances of coffee makers and microwave ovens to larger appliances of refrigerators, washing machines, and air conditioners, our homes are furnished with appliances for our convenience. Outside the home, our workplaces, office spaces, warehouses, manufacturing, and industrial facilities all function on electricity. Even our shopping and entertainment experiences have not escaped the dependency. Whether it's the modern indoor malls or arenas and concert halls, gigawatts of electricity are needed for everything from heating and cooling the facilities to the food courts to keep hungry consumers going. Of course, our electronic or communication devices, such as TVs, laptops, cell phones, and video games, may not consume as much, but all function on electricity. Even our transportation means are becoming electricity dependent. More and more cities are utilizing electric buses and trains for their public transportation. At the same time, consumers are transitioning from traditional combustion vehicles to electric vehicles. On a bigger scale, modern cities today are as bright at night as during the day thanks to the power of electricity. New cities are flourishing from the deserts of Nevada and the Middle East to the freezing tundra of Europe and Canada. This is all possible with the help of modern appliances, such as air conditioners and heaters. In addition, large pumps powered by electricity help irrigate and supply drinking water to dry cities like Las Vegas and Dubai. According to U.S. Energy Information Administration, electricity consumption in the United States has been trending upwards from 500 billion kilowatt-hours in the 1950s to nearly 4 trillion kilowatt-hours today, an increase of 700% in just a few decades. All three major sectors, industrial, commercial, and residential, each consume slightly over 1 trillion kilowatt-hours of electricity annually. Global trends are similar, increasing from 5 to over 20 trillion kilowatt-hours during a similar period, with industrial consumption outpacing both commercial and residential. As global economies grow and populations modernize, the electricity demand is only going to grow exponentially. Over the next few videos, we will address the many different technologies scientists and engineers exercise to keep up with ever-increasing demand. We will focus on the traditional ways of generating electricity, such as coal and natural gas-based power plants, as well as generating electricity from renewable energy sources of wind, water, sun, geothermal, and others. But first, what is electricity and how is it generated? Is it a local commodity that can be supplied to every community with ease? If so, why do some regions generate electricity with ease while others struggle to produce enough for basic necessities? Most importantly, can our modern economies function without it? Electricity is the flow of electrons between atoms. An atom is the building block of every living thing. An atom is made up of three particles: neutrons and positively charged protons, which reside inside the nucleus, as well as negatively charged electrons, which reside outside the nucleus. Electrons orbit the nucleus in multiple paths. Those orbiting on the closest paths to the nucleus are strongly attached to the protons inside the nucleus. However, electrons orbiting on the outermost paths are not strongly attached to the protons. These electrons can be pushed out of their orbits into other atoms and start an electron chain reaction, which is an electric current flow. One way to push the electrons out of their orbits is to provide an outside force, such as a magnet. When an atom is struck with a magnet, the magnetic field forces a breakup of the electrons, creating free electrons. In the case of using a wire, electrons' movement occur with every sweep of a magnetic field. The movement of these electrons is what is known as electricity. Atoms that have electrons held loosely can pass electrons to other atoms. These are known as conductors. Most metals are conductors. On the other hand, atoms that do not pass electrons are known as insulators. Examples of insulators include rubber and glass. This is the reason electrical wires are made from metal conductors like copper that allow the movement of electrons and are insulated by rubber to protect us from electrical shock. Electricity is a natural energy. It exists in nature when friction is created between two elements and electrons are discharged. For example, we create friction when we rub our feet against a carpeted floor or when we rub a balloon against our hair. The friction between the carpet or the balloon and our body creates the movement of electrons from the objects to our body. We witness the movement of electrons by the shock we feel. In nature, friction is created when clouds collide. The thunder we hear and lightning we see are the movement or discharging of negatively charged electrons from one cloud to another or from a cloud to the ground. This kind of electricity is called static electricity. It is stored energy, all released at once. In 1832, Michael Faraday discovered that electricity can be generated by moving electrical conductors, such as copper wire, in a magnetic field. The spinning of copper wires between magnets creates an electromagnetic induction, which is electricity. This kind of electricity is known as current electricity. The process of generating current electricity requires a generator which is comprised of a large coil of copper wire, spun using a turbine. The turbine is attached to the generator using a series of shafts. Spinning the turbine spins the generator, where the electricity is generated. Traditionally, turbines are driven using steam or combustion gases. The electricity created by the generators is then transmitted from the power plants to cities and neighborhoods using metal conductors on the transmission lines and power poles that line up our cities. Finally, transformers are used to reduce the transmitted power to a lower voltage at local substations before being distributed to industries, businesses, and homes. For additional information, viewers can purchase additional publications from Rev Engineering. The latest publication, Renewable Energy, There is Nothing New Under the Sun, is designed to introduce the reader to the old and the new ways we use energy, especially in the generation of electricity. The book looks at the history and development of both fossil fuels and renewable energy sources and focuses on the shifting trend we are witnessing today. Coal-based power plants are declining and being replaced by natural gas, nuclear, and renewable sources plants in the United States and globally. As the subtitle implies, these sources are not new discoveries. Wind, solar, geothermal energy have all been used since ancient times for mechanical work, such as for irrigation and flour milling. Today, renewable energy sources are used for generating cheap electricity. The second half of the book introduces the many different types of renewable energy sources such as wind, hydro, solar, geothermal energy, bioenergy, and so on. Government policies, tax incentives, and technological advancement have contributed to a cost reduction of 70 to 90% in just a few decades. Currently, solar and wind power are the cheapest sources of electricity. The book further explores the technological development of many of these energy sources. Some of the largest hydropower plants, wind farms, and geothermal plants in the United States are studied to introduce the reader to the technologies and engineering work that take place in these plants and how they have evolved over the years. Finally, the book addresses the contribution of the renewable energy industry to the job market. According to the U.S. Bureau of Labor Statistics, the sector accounts for nearly 50% of all employment in the energy sector, contributing to local economies everywhere. This publication can be purchased on Amazon and Ingram Spark.